Okay, so I'm now going to do a quick overview of 3D printing, and I'm going to talk about how they work. This is a Prusa 3D printer. This is based on an open source model called the RepRap, which I'll go into in a minute. Modern 3D printing is basically just a method of melting plastic to build shapes, and we can do it in all sorts of stuff. You may have noticed that I set up a 3D print for you to look at on the way in and out today. It's just by the door room next door. There's an operating system. It uses the Arduino Mega, which is a really powerful Arduino. Some of them, well, this is kind of like the highest one of the 18 mega chips before we start going into ARM processors. There's an operating system that's been built all open source, and the operating system is called Marlin. And you can have a look at this if you wanted to. You can download it. You can install it onto a Raspberry Pi. Onto a Arduino Mega. And there are other versions available, and it's constantly in development, right? The software basically reads in a long file called G code, and it reads it in line by line, which makes the code. Which makes the motors move in various different ways. So we've got a motor that's extruding the plastic, we've got a motor that's doing horizontal, we've got a motor that's doing vertical, and another one that's doing the x-axis. And this is called G code. And if we have a look at this, it basically looks like this. This is one that's been generated by a Prusa slicer. And we've got some information here. And then we've got these numbers, M73, P0, R117, M201X, blah, 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 blah. So this is actually set in the parameters of what the 3D printer is going to do. And then as we go through this, you can see that this is a very, very long file. And this is for the little, it's called Benchy, the little boat 3D print that's going on outside right now. And this is what it's doing. It's telling it, okay, so these are the position. I want you to go into this position for this long. Go to this position for this long. Go to this position for this long. Go to this position for, move to X. Move to Y. Extrude. So that's what it is. So, and this is telling it what parts is. Now, if you wanted to go into this, you can do. But yeah, it's an RS standard. So you can see down here, if we look for G, so G often tell what kind of control, what kind of motion is wanted, whether it's rapid positioning, linear feed, circular feed, etc. Okay? So that's how a 3D printer works. It basically just takes this very, very long file. As you can see, it's really long. And then once it finishes, it can do some other commands, right? It can do some other things like, say, flash a light, or move the tray really forward, or, sort of like anything else. So that's doing at the end. So that's how 3D printing is done with the Prusas. Okay. So the way that it does that is we need to take a 3D file called an STL file, and we put it through a slicer. Who's done 3D printing before? Okay, not so many. I'm just going to show you then very quickly how we do that. So we've been using Tinkercad so far for doing our Arduino things, but it also does designs. So Wi-Fi's been really bad at the moment. Thank you. That was at Mont Blanc, I think. Anyway, new 3D design. It's been really, really slow. I'm going to turn this off. Okay, while that's loading, I'll go on to the next slides and talk about these other bits and pieces. So the history of 3D printing. Basically, in 1984, well, earlier than that, people came up with ideas about how you might want to do 3D printing. But in 1984, Bill Masters got the patent for doing any kind of 3D printing. So it's kind of like stuck with him. But that patent ran out in 2004. And so this caused an absolute flurry of people like just dying to try out this technology and giving it different ways, of different ideas in different ways. And the RepRap was born. This is a replicating rapid prototyper. That's a 3D printer that prints a 3D printer. And the very first one is in the Science Museum in London, if you want to go and have a look at that. It was invented by Adrian Boer. And the principle is that it can build itself, except for all the nuts and bolts and all that kind of stuff that you can get standard off the shelf. The same with the motors. There's a video on this slide which I highly recommend you watch, like for your homework. And then there's a history of 3D printing on all 3DP, which is basically the history of the RepRap. And this basically like gave us the ownership of 3D printing again. And I also put on our thing here a TED talk that I found the other night of a guy who is doing this in South America, where it's very expensive to import parts. Who's actually building prosthetic limbs from using 3D printing. So I highly recommend you look at that too. All right, let's go into this. This is a really, really simple, easy interface to build something with. We can take a little block here and plot it somewhere. And we can see, if I hold this over, that this is 20 millimeters by 20 millimeters by 20 millimeters. And so I can move these up and up. Sorry. If I press Control, I can move the plane around and click with the mouse. This gives us the height, so maybe I want it 5 millimeters, and maybe I want it to be, I don't know, let's go for 70 either side. So a bit more this way, a bit less that way. So now I've got a nice 70 square, right? I can also move this up a bit and place it anywhere within the plane. But of course, if I start doing things like that, now we can't print in midair, can we? So, like, if the print head is going around, we have to be very cautious about how we build a structure that builds up from the plate. Okay, just going to point that out. If I now want to do something else, like put a hole in it, I can take an object like this, and I can either make it solid, or I can make it a hole. And if I wanted to make it really, really round, I can increase this. And if I want to push it all the way through the object, I might put it below the pane, so you can see it's coming through like that. Okay, and maybe I want a little dome as well. And but I want the dome to go like sort of like that. But I don't want this bottom bit here, because that's below the pane. It won't print anyway. But if I was going to do multiple bits, I might take a box and put that below. I can see now that that's not covering it. Make it cover it. Okay, and now I can see, oh, it's not quite there, you see, so I can move it up a bit more. Now it might go into the thing. Now I select all of this. When I group it, it will take away all the bits that I add holes. Now you can then take this and then do that as a copy and paste it there. So I could now use this and say, I want this to be a mold in here, and make that a hole. And the whole object then becomes a hole. So this is how you very quickly build something in Tinkercad. I'll undo those things, get rid of that. And say, like, if we're going to go for a keyring, I might just put this here. I'll put my, for some reason it has a really ugly font as standard. Oh. Okay, and now I've got that a little bit taller, so that will print out quite nicely, I think. So now, once I've got something like this, I can select it all, group it, and then I can export it as a STL file. There's various different objects here. If you wanted to take it into other software, this is where you would do so. STL. Okay, and now what we need to do is slice it ready to turn it into G-code, so our printer can understand it. I'm using Ultimaker Cura, but there are lots of different slicers out there. The one that comes with Prusa is called Slicer with a 3, and that's all open source as well. Cura is actually for Ultimator printers, but I set this up so that we can use our Prusa here. So the next stage would be to bring in the model that I just saved, wherever I saved it. Where did I save it? Sorry, I'll just save it out again because I don't know where I saved it. STL. Oh, it's just, okay, it's just done it here. Show and find it. It'll be in downloads then. Okay. I can just drag this in here, and you can see that it's ready to print. And it might be that I want to do multiple ones, in which case I can just make copies and so forth. And you can do all this in here. And you've got precise information about where everything's going to be laid out, all down this side. It's always complaining about that, don't have to do that. So the next things are, we have to work out what kind of filament we're going to use. Now I'm using PLA, which is the Prusament filament. Most of the stuff that we've got here is PLA. In fact, I don't think we let you print in anything else. And I bought a load of Prusa Research PLA. So Prusament is what it's called, usually. And so we're telling it that we're using that function tells the printer and tells the encoding software, the slicer, what temperature and at what speed, and all of those kind of things that you might want to print at. And these are the things that you need to refine for every print that you're doing. You can do so in this pane here. You can choose various different, so you have a recommended level, right? So this is like the very simple sort of layout. You want it at 0.5, you want it 20% infill. That's the infill that it's going to give, so it's not solid. 100 would be completely solid, complete plastic. 20 builds inside a vacuum, so it's nice and light. If you're having problems sticking to the board, you might want to turn on adhesion or support. I'm just going to bring in Benchy to show off one of the little aspects. So here we have our little Benchy boat, and you can see here that we've got little red bits underneath. These are the bits that are not supported, and so you need the settings need to be at such a level that the print is stable enough at a certain height for it to then go a little bit in and a little bit further in and a little bit further in, and then set. But there is, if you have something that is like really hanging in the air, then you're going to want to build support, which is what this button here does. And there's various different ways that you can build support. You can build it in a tree-like structure. You can have it as a very mathematical grid structure. And if you wanted to change all those kind of settings, you can go into custom. And as we said, our material, we want, so most of the things in our lab, if you wanted to use our printers, print at 215 and the bed about 60. But if you're having troubles printing and it's not sticking to the bed, or if it's pulling itself off the bed, slow this right down. The general speed is at 60, but if you bring this down to 20, it will take a lot longer, but you get a much better result. And the other thing is, so we've got support. So here in support, we might want to just do it anything that's not touching the build plate, which in our case would be the hull of this bed, right? Because that's touching the build plate. But if we put it on everywhere, it would not just do the hull of the ship here, it would also build support in here. Now the problem with support is that you have to then remove it all afterwards, and so you don't really want as much. You want to use as little support as possible. Okay, And the same goes for build plate adhesion. There are various different ways of doing it. And okay, right. So the one thing we can do now is slice this. And this is creating our G code. Now I've got 3 models on here. How long do we think that will take to print? Oh, 13 hours, 51 minutes. Wow, that's a long time. Okay, so I did lower that speed, right down to 20. Let's put it onto 60, which is the recommended speed. Okay, now it's 6 hours and 2 minutes. What we can do in this is click on preview, and we can see what it's building. Like I said, because we've got the support selected, it's building these supports around here. You see the blue there, and if we move the progress level right down, we can see what it's going to actually do. And if I move this around, you can see that it's got a little version of what the print head's going to do. So you can go through the print and check that it's going to do what you think it's going to do before you then start going and put it on the printer. And you can just go like this. Boom. Okay, sound effects. I'm going to turn off the support and then slice it again. Okay, so the support was adding like an hour. So, you know, and I know that this is long enough for it to, this is an angle enough that it will work. But you need to play with this and work this out for yourself, you know, like, so you can do all sorts of different ideas and such with this. You save this image out, this to disk, and then you put the USB or memory stick into your printer and then set it going on the printer. But I set up some monitoring for some other printers, but we'll go into that another time. All the information is on the wiki. What else do I need to go through? Yeah, that's the other thing, is once you don't know who's been using the printer before you, you don't know if it's calibrated properly, so always do a calibration test, and that's the first layer test. On the printer it has a setting, and it just says, can we do a first layer calibration, and it will check, and if the filament sticks quite nicely to the plate, then you're ready to go and you can print your own print. And then you can say go in. All right, at CCI we've got 3 Prusa 3 printers, which are 20 centimeters by 20 centimeters, and check the wiki for more information. And okay, so I think that's all I've got to say about 3D printing. Any questions? Also on the wiki there is a list of places. The Wi-Fi's not working again. This is no good. Oh, wiki.cci.arts.uk. Wi-Fi is working, my fault. So in physical computing, where to buy material parts, where to buy components, there's the e-textiles, there's useful resources and our how-to guides, which tell us about how to use all these things, which we'll go into in a week or so. But there's also hack spaces and services. So if the printers here are too busy, or if you want to just send it off and get it made, this is where to come to try and find those services. Okay.